Hello everyone, welcome to my channel. This is an educational channel. We are looking into the reciprocal system of theory, and this is the 172nd video we've done on this. We are in the middle of his book called Nothing But Motion. This book came out in 1979, and this reciprocal system of theory was authored by Dewey B. Larson, as well as this book, one of his many books. We've gone over quite a few of them so far, books, articles, and speeches, and interviews. And the basic idea behind the reciprocal system of theory is that we live in a universe of motion. The universe is not made out of matter. It's not made out of energy, but is made out of motion. And motion is the relationship between space and time. So time and space are generally considered to be the container of the universe. We think of motion as kind of we think of the universe as kind of a drama that is occurring in empty space, and that the actors on the stage, whatever they may be, are acting in space and through time. But in Larson's universe, space and time are actually not the container of the universe, but actually the contents of the universe. So not only are the actors acting in space and in time, but the actors themselves are space and time. And when you say that motion is the relationship between space and time, it sets up a fractional relationship. And basically, time or space is the numerator, and space or time is the denominator. Space and time both have the same qualities. Larson calls one of them coordinate aspect. There is coordinate space and coordinate time. They both come in 3 or more dimensions. Larson saw them as X, Y, Z coordinates. And then you also have what he calls the clock aspect. Space and time are both, have their clock aspects. They both are progressing. Time is always getting later and later and later. Space is always getting farther and farther and farther apart. This is what Larson calls a scalar motion. It's a motion that has a magnitude, but it has no direction. You envision this using a balloon and a magic marker. You put a bunch of dots on the balloon, you blow up the balloon, and the dots are all moving away from each other, but not in any particular direction. And then you suck in the balloon, and the dots are all moving toward each other. Those are respectively called outward scalar motions and then inward scalar motions. So time and space both have that aspect to them. They also both come in discrete units only. There is a minimum unit of space and a minimum unit of time, and below that there isn't any space or time. Actually, within 1 unit of space you have only time, and within 1 unit of time you have only space. Larson calls these the time region and the space region. He really divides the universe into 4 regions. You have the time-space region, and then within that you have the time region, and then you have the space-time region, and within that you have the space region. And there are boundaries between them, and when you cross those boundaries, the rules of the universe switch up a little bit. In some cases, they invert. We'll see that when we talk about atomic phenomena. Atomic phenomena are phenomena of the time region, and then on the other side of that, you would have inverse phenomena, inverse atomic phenomena. That would be a phenomena of the space region. So when you have exactly 1 unit of space in 1 unit of time, that is the speed of light. And so the speed of light is the boundary. The three boundaries are the speed of light, unit time, and unit space. 1 unit of time and 1 unit of space. Those are the boundaries that set up this universe that Larson is talking about. Now, this book that we're looking at is called Nothing But Motion. It's the first book in his 3-volume set called The Structure of the Physical Universe. It's mainly on physics. And we are in chapter 9 of this book that is called Rotational Combinations. And a rotational combination is referring to atoms and subatomic particles. And just to preface this, there's really 4 different kinds of motion. You have your translational motion, you have your vibrational motion, you have your rotational motion, and you have your rotational vibration. But these motions can also occur in at least 2 dimensions and in some cases 3 dimensions. So an atom is basically what you need first in Larson's system is that you need a photon to start the atom. And the photon is a simple harmonic motion, which is a wave-like motion, which comes about in Larson's system as the result of both a vibration and a translation. So, if you superimpose those 2 things, you've got this vibrating thing at a 90-degree angle to the translating thing, and you end up getting a simple harmonic motion. Some of Larson's followers eventually said that no, the simple harmonic motion is as a result of a birotation, 2 rotations superimposed on each other. That creates also a sine wave. And I believe that is Leonard Euler's epsilon function originally. And I tend toward the birotation, but I don't have a lab or anything where I'm trying to prove that or anything. An atom, you've got to have that simple harmonic motion first, and then once you have that, then you can superimpose a rotation or more than one rotation on that. He said once you have this, if you then go 90-degree angle to the simple harmonic motion, and you superimpose a rotational motion, then you have a disk. And then if you superimpose another rotation on that, then you have a sphere. And so that is, what the atom is. It's basically 2 rotational motions superimposed on a photon at the right angles. And then there can also be another kind of backwards rotation that is superimposed on those. That would create what you would call the periodic table, where those first 2 motions really just create the noble gas series. Okay, now we're going to try to get into discussing this. He's talking about in this chapter about these compound motions. So let's let him speak here, and through my reading. And here it comes. When a compound motion of this type, a rotation of a vibration, is formed, the inward motion due to the rotation replaces the outward motion of the progression of the natural reference system. Now, remember, the progression of the natural reference system is an outward scalar motion at the speed of light. Okay, so that is what Larson is considering to be the 0 point of the universe, or the origin, or the null point, or the background of the universe. Is the progression of the natural reference system. Everything is moving outward at the speed of light in all directions, and that's always there. Okay, that's the 0 point. That's always there. But then when you have this rotation of a vibration, that inward motion is canceled out. Okay, so the inward motion due to the rotation replaces the outward motion of the progression of the natural reference system. Thus, the components of the compound motion are not subject to oppositely directed motions in the manner of the multi-unit rotating photons, and these components do not separate spontaneously. However, the rotational displacement of the photon now under consideration is negative. If the rotational displacement applied to this photon is also negative, the displacement units, being units of the same scalar nature, are additive in the same manner as the vibrational units of a photon. Like the photon units, they are easily separated when even a relatively small force is applied. And the rotational displacement is therefore readily transferred from the original photon to some other object under appropriate conditions. For this reason, combinations of negative vibrational and negative rotational displacements are inherently unstable. On the other hand, if the applied rotational displacement is positive, equal numbers of the positive and negative displacement units neutralize each other. In this case, the combination has no net displacement. A motion that does have a net displacement cannot be extracted from such a combination without the intervention of some outside agency. It is simple enough to separate one negative unit from an aggregate of n negative units. But getting one negative unit out of nothing at all is not so easily accomplished. A combination of a negative vibration and a positive rotation, or vice versa, is therefore inherently stable. All that has been said about additions to a photon with negative displacement applies with equal force, but in the inverse manner, to the addition of rotation to a photon with positive displacement. Now, just remember, displacement is basically his word for plus or minus the progression of the natural reference system. So if something has positive displacement, that it means that it's moving faster than the speed of light. If it has negative displacement, if it has positive displacement, it means it's moving slower than the speed of light. If it has negative displacement, it means it's moving faster than the speed of light. He uses that inversion because we live in the universe that is moving slower than the speed of light. That is what we perceive. And that is why Einstein said that the speed of light is the maximum speed of the universe. That is true for the material sector. That is the sector that's moving slower than the speed of light. But there's an entire universe that's moving, or half of the universe that's moving faster than the speed of light. Larson refers to this as the cosmic sector. This sector has more to do with life phenomena and especially mental phenomena. And this is the universe that is motion in time. It's motion moving faster than the speed of light, where unbeknownst to Einstein, this half of the universe, it's not that the speed of light is the maximum speed of the universe. The speed of light is the minimum speed of the universe. And this sector is unseen by us because it is in time. We see space, but we do not see time. When we our observed motion in time, we observe it as a motion in space in its reciprocal aspect. So if we see a motion in time, we actually see its inverse as a motion in space. And this was reflected by in Larson's astronomy by the white dwarf star. So the white dwarf star is an explosion in time. But when an explosion occurs in time, we see it in space as an implosion. So the white dwarf star is very, very small and super dense because it's exploding in time. So in space, it's very small and very dense because we see an explosion in time as an implosion in space. And so as a result of our residing and sensing, making our measurements in this slower than the speed of light half of the universe, when a displacement slower than the speed of light, he calls that a positive displacement. But it's technically would be really negative. Okay, so but in the inverse manner, to the addition of rotation to a photon with positive displacement, that is, it's moving slower than the speed of light, we therefore arrive at the conclusion that in order to produce stable combinations, photons oscillating in time, meaning negative displacement or faster than the speed of light, must be rotated in space, which is the positive displacement, which means it must be rotated slower than the speed of light, whereas photons oscillating in space must be rotated in time. This alternation of positive and negative displacements is a general requirement for stability of compound motions, and it will play an important part in the theoretical development in the subsequent pages. It should be understood, however, that stability is dependent on the environment. Any combination will break up if the environmental conditions are sufficiently favorable. Conversely, there are situations to be examined later in which environmental influences create conditions that confer stability on combinations that are normally unstable. The combinations in which the net rotation is in space, positive displacement, can be identified with the relatively stable atoms and particles of our local environment and constitute what we call the material system. For the present, we will confine the discussion to the members of this material system, slower than the speed of light, and we'll leave the inverse type of combination, the cosmic system, as we will call it, for later consideration. Inasmuch as the oscillating photon is being rotated in 2 dimensions, the basic positive rotation, 1 unit of 2-dimensional positive displacement is required to neutralize the negative vibrational displacement of the photon and reduce the net total displacement to 0. Because of its lack of any effective deviation from unit speed, the reference datum, or the progression of the natural reference system, this combination of motions has no observable physical properties, and for that reason it was somewhat facetiously called the rotational equivalent of nothing. Okay, this is basically that the progression is being canceled out. So you have nothing, you have just an entity, but it's nothing. Again, he says the 1 unit 2-dimensional positive displacement is required to neutralize the negative vibrational displacement of the photon and reduce the net total displacement to 0 in the first edition. So, but this understates the significance of the combination. While it has no effective net total magnitude, its rotational component does have a direction. The idea of a motion that has direction but no magnitude sounds like something like a physicist's version of the Cheshire Cat. But the zero effective magnitude is a property of the structure as a whole, while the rotational direction of the two-dimensional motion, which makes the addition of further positive rotational displacement possible, is a property of one component of the total structure. Thus, even though this combination of motions can do nothing itself, it does constitute a base from which something, a material particle, can be constructed that cannot be formed directly from a linear type of motion. We will therefore call it the rotational base. Okay, so that is an important concept that you have to get this, the rotational base. Now, again, I hope you're not getting discouraged by this. This is difficult stuff and it's hard conceptually. A lot of times it's hard because you've already learned a different system that you kind of have to unlearn to learn this. But just remember that basically what we're doing here is we're learning atomic physics. You know, you don't just learn atomic physics, you know, in a 20-minute video. If you went to school and you studied atomic physics, it would take you a long time to learn it. And it's going to take some time to learn this too. This is a lot simpler than what you would learn in school. And Larson brings the receipts as well. Like when he goes through this, he will be producing tables and numbers that, experiments that back up his claims, that show, he predicts the qualities and of these various atoms that he comes up with. He calculates the pressure, the temperature, the melting point, the boiling point, and so on, and they agree with the actual calculated values. So he's not just, giving you philosophical stuff. He comes up with the receipts. Okay, thanks a lot. Have a great day. We'll see you later.